Hey, it's Dino here with another Apigee Tech screencast. Today I want to talk about external authorization. Now, if you know anything about Apigee, you know that there's some basic access control that you can do in an Apigee API proxy. It's really easy to configure Apigee to accept an OAuth token or an API key and to verify that with either the OAuth v2 policy or the verify API key policy, respectively. Um, when you do this in your API proxy, either the caller has presented a valid, unexpired, unrevoked key or token, or it has not. So it's basically a yes or no kind of check on that inbound credential. Apigee extends that basic yes or no check with this idea of the API product, which is just a collection of verb path pairs that will be permitted for a particular credential or app. Then at runtime, Apigee verifies not only is the credential valid, but is it valid for that particular verb path pair that the current API request is using. And that's really handy. I've got a 15-minute screencast review of that concept, and you can check that out with the link here. But what about more flexible controls? Some customers are looking for something a little bit beyond that, not just checking whether the credential has access to the verb and path, but does the user have access to it? So role-based access control, or something a little more general, maybe attribute-based access control, where the access control decision is not just based on the role or identity of the user, but maybe some additional data like time of day or the project name or the MAC address from which the request is originating or something else. Apigee does not have a good mechanism by itself for performing either user by user RBAC or the more general ABAC. But there is a typical pattern, and that is for customers to externalize the access control decision and then use Apigee to enforce the decision. So basically, Apigee collects all the information it needs, sends that to an external access control system. That system makes a decision based on rules and so on, sends it back to Apigee, and then Apigee enforces that decision. The example that I'm providing here shows you how you can implement this pattern using a custom Cloud Run service that externalizes the access control decision for an API proxy. So the implementation here uses Google Sheets to store the access control rules. And the rules are things like for a user with this role, requesting this resource with this verb, allow or deny it. And if it's an employee, then I want to allow a get on /T2. If it's a partner, I also want to allow get on /T2, and so on. So I can stipulate those rules in a fairly convenient table in Google Sheets. And then the access control service reads the sheet and then implements those rules. So pretty neat. The pattern is what I want you to focus on here. The fact that it's using Sheets as the data store, not that important. It also happens to use C# as the custom access control decision point. Also, not that important. That's just an implementation detail. The idea is the thing that you should take away here is the pattern. Okay, so a lot of people have looked at this and said, hey, why wouldn't I use Open Policy Agent for this? OPA is a good solution. It's general, it's open source, it's well maintained. It's available just as a deployable container, so you can just drop the container image into Cloud Run and invoke it. The only drawback that I've seen with OPA is that it depends on Rego to express policies. And Rego can be kind of um, it's novel. Let's just say it that way. For some people, it is hard to figure out, sort out, and that can be an obstacle. So for this particular example, I wanted to use something a little more approachable. Google Sheets is visual. It's easy to update. It's easy to protect the sheet. It's easy to get an audit log. You know, it's all sort of just built into the Google Sheet idea. So that's why I wanted to use that. But you can use anything. Okay. So for the rest of this, I want to walk through deploying this example and showing you how it works. You can do this yourself, and I've got a bunch of tools and scripts that sort of help you set it up. So let's walk through it. The prerequisites, obviously, you need an Apigee organization. You need a Google Cloud project with Cloud Run or Cloud Build installed. You need a workspace environment where you can create a sheet. If you're going to do modifications to the Cloud Run service, you need .NET 8.0. If you're not modifying it, you don't need .NET. And then various tools just to run the setup things. You can get all these in Google Cloud Shell. So let's just kind of get started. First thing is there's an environment file that allows you to specify all the things that, all the environment settings that you will need for this example. That's an Apigee project, the Apigee environment, a host name at which your Apigee API proxies will be reachable, a Cloud Run project, which may or may not be the same, a region for Cloud Run, and then the name of the service for Cloud Run and a short name for the service account. You can change these things if you like. You don't really need to, um, but that's all the kind of choices that you need to make. I've got my own in a private file here, so I'm just going to source that, and now I have all my settings. So next step is to enable the services. So let's copy that, flip back over to the terminal, and we'll enable the services. Really, it's just going to make sure that Cloud Run and Cloud Build are available. Nothing real exotic. By the way, for any of these scripts, what I try to do is make them fairly simple. So, you can have a look inside and see what they do and, before running them if you're curious. All right, so the next thing is you need to you need to sign in with gCloud, and this is going to allow the next script to create a spreadsheet. So let's copy that, flip over to the terminal, and this is going to say, hey, do you want to continue? Basically, we're asking for the application default credentials to be able to create files in Google Drive and create a spreadsheet. So you kind of need to do that in order to use that sheet. If you don't want to do this, you'll have to manually create the sheet according to that snapshot that I showed in the README. So, but let's go through this. I'll just paste in that URL. It's going to say, hey, do you want to sign in? Do you want to allow this thing to do those, the things that it's asking for? If you agree, just agree, and then copy the code and paste it in here, and then you should be all good. So that's the auth login step. That takes just a moment. All right, so we've logged in. Now we want to create the sheet, and this should be fairly automatic. This is a Node.js script. It uses the credential that you just authorized and the REST API for Google Sheets to create a sheet. So let's grab that URL. That's fairly quick, and we'll flip back over to the browser. This is what it looks like. So if you don't want to run that script to automate the creation of this thing, then you can just kind of manually set this up yourself. But the idea is, you got to fill in columns to allow and disallow these actions based on the role. What are these roles? In my example, I've mapped email addresses and patterns of email addresses to different roles. So basically, the inbound request is going to carry an email address, and we're going to map that to a role. And then once we have a role, we're going to map that role to a set of permissions and then enforce that inside Apigee. Okay, so that's the sheet. We have created the sheet. We need to make sure that we grab that sheet ID. So let's go back to the terminal and copy paste this to set that environment variable. We're going to need that later. All right, so we've done that. Now create the service account. So nothing really exotic there. That's just going to create this thing you had specified in your your environment file. But now it tells you, hey, you got to share the sheet with this email address. So copy the email address, flip over to your sheet, this thing, and share it. This is one thing that's not automated. Just paste in that that address. It doesn't need to be editor. It's okay if it's editor. It really needs to be commenter or viewer. You may get a warning that says, hey, this is external to your project. Are you sure you want to do this? Just agree, and you're sharing now this sheet with the service account. Okay, so we've done that part. Now we're going to deploy the cloud service. This will take a few seconds. So let's clear the screen. Basically, it's using the Cloud Run deploy from source approach with gcloud. This is the command that it runs. And it is just deploying the source code that is resident locally. It's going to take a few minutes. Let me walk you through it. Okay, there's an access control service, and I told you that it was implemented in C#.NET, so nothing really exotic here. The one thing that's maybe notable is a gRPC service. And the Apigee is going to be calling into this gRPC service that's implemented in Cloud Run. So basically what it does is, let's kind of scoot down. This is the inbound message, process message, and it's going to get the access control subject, it's the caller, the action, that'll be the verb, get, post, put, delete, the resource, that'll be the API proxy path. It's getting all of this stuff that has been set by the API proxy and sent in, and then just evaluating access for that tuple, for that combination of things. So what does evaluate access look like? It's right here. The first thing it's going to do is resolve the role. And that is going to be mapping from the subject, which is an email address, into one of those roles. That's basically doing what I described a little bit earlier. It's looking through here. Does the subject email match, exactly equal any of these, or does it match the pattern that's expressed here? And if so, then we're going to map it to this role. So that's what this resolve role thing does. And then for each of the rules, that would be here, for each of these rules, it looks to see if there's an allow, basically the inbound request and the verb for that particular role. Does that match, and do we allow or do we deny? And that's what this this logic is doing. So relatively simple. Nothing really exotic here. So that's the C# logic that implements the access control. Okay, so what we did in step 5 was just deploy that, and it's now available as a gRPC service at that endpoint. Everything looks good. It all kind of looks like it deployed successfully. So let's go back to the README. We've deployed it. We need to install Apigee CLI. I already have that installed, so I'm not going to run that step, but you should. We need to create the target server, so let's copy that. Flip back to our terminal. It's basically going to create a gRPC target server with this host name in it to allow the API proxy to access that Cloud Run service. So that's fairly quick. And then the last thing is just to import and deploy the Apigee API proxy, which I didn't even show you yet. But I will as soon as it's imported. Yep, it's imported now. So let's flip back over. There is my access control API proxy. Flip into the develop tab and we'll have a look. So you can see it's not real. It's a loopback proxy. It doesn't connect to anything upstream. It's not real exotic. It has a preflow where it does the external callout, this EC1, which I'll show you in a minute. And then if that passes, it'll handle a get and a post. But you can see there's no policies attached to either of these flows. It's not doing anything really exotic. The most interesting thing is this part here, is this EC. Now it does does check to see that the header, the access control header, is present. If that header is not present, basically that's the way the caller is going to send in the subject or the email address that should be checked. If that's not present, you get a fault. But after that, we're gonna just assign some access control variables, and that's the subject getting from the header, the action, which is just a verb, as I said earlier, and the resource, which is the proxy base path and the path suffix. So if I flip back to my C# service, my access control service, that's these things. We're basically setting these variables that then later the access control service will be able to access. Okay, so we've set that in the access control or the assigned message. The next policy in the flow is this external callout. Now, external callout is something that you may or may not be familiar with. It's like a service callout, but it allows you to call a gRPC service with a particular name. And the name I'm using is example access control server. That's the target server that we created in the shell script a little while ago. And basically, it's passing any flow variable that has this as a prefix. So it'll be access control subject, access control action, access control dot resource, and so on. And all of that is then accessible by the C# service. And then when we get the response back, let's just flip back to the flow. When we get the response back, we can check if the result is not allow, then we just send back a access denied response. If it is allow, then flow continues, and we can go into our conditional flows. All right, so pretty simple. Maybe we'll turn on a debug session. This should be deployed by now. Let's look. Yeah, it's deployed. And it's at the end of the deployment script, it gives me some example curl calls that I can invoke right from here to test it. It says these are expected to succeed with the default rules. And I'll explain this. So I'm sending in that header with the email address. It's then resolving that to a role and then checking it against a get on this path. Okay, so get on /t1 with that particular email address. Should it succeed or not? Well, we think it's going to succeed. So when I send this through, yep, in fact, it succeeds. Let's check one more time at the roles. So person at examplecompany.com was the name, and that is this. So that gets mapped into, because I sent that email address, that gets mapped into the role of employee. And then I'm looking for a match, employee on /t1. Well, there is no match, but it falls back to this any, which is a special term that I put into this example. And anybody that calls in can invoke this. So that's kind of example one with the fallback. If I also change this to /t2, because T2 is allowed by employees, that's going to be allowed. Right? So T2 is here. We're sending a get on T2 for an employee. That's allowed. There is no T3 for an employee. So let's check that. If we send in a T3, we would expect that to be denied. And it is, because there's no rule for that. However, there is a rule for T4 here. So if I send in a request for T4 for that same email address, that should be allowed. Okay, so that's just basic access control rules. Now let's look at some of these others that should fail. A post on T1 is not allowed by anybody. So if I send that in, that should fail. Access denied as expected. These other ones should fail. You can explore. The other thing you can do is you can modify these. You can add in new roles if you like, new rules for the existing roles, new paths, verbs as you wish. But you should be aware that there's some caching. The service caches the roles for 3 minutes and the rules for 2 minutes. So you kind of have to wait a little bit if you modify that sheet and expect the before you can expect the results to be seen in the runtime service. If I go back to my Apigee, I can see the various checks, and here's one that was approved. We can see it calls out to this external call out. The variable that the variables that get sent are all those access control variables, and then for the subsequent policy, we check the access control result and see that it's not that it is allow. So the flow continues. For this one, we get a denied. So the raise fault says, oh well, you're going to be denied. Access control was not permitted. And so you can see all that. The other thing you may want to check is the logs for your Cloud Run service. So let me just open up Cloud Console in Cloud Run. And it looks like this is the service. And I can check the logs and see what the service has been receiving and the decisions that it's been making. And you can see it gets these requests in, looks for the role, finds the employee, and so on. I don't know. It's just an interesting way to kind of have a look at what the service is doing. So you can look at both of those. You can change the C# code if you want, modify this stuff around. You can change the API proxy to send different information in for the access control decision. All of that is within your power. Finally, after you're all finished, you can clean up, you remove the Apigee assets, remove the Cloud Run assets, including the service account, and then manually delete Google Cloud Sheet, and you should be all good. And so that's it. That, I think, is a good example of externalizing access control for Apigee API proxies using kind of a handy data store, Sheets, which gives you a bunch of advantages. I hope this has been helpful. Till next time, keep it digital.